Hello, friends. It is Ben again. This is a video intended for Monday. I guess that'll be the 1st of May. So, May Day. The intention of this video is to go over what I'm looking for in the assignment we're doing. Now, I should say that the things we're doing this week are a little bit different than what we did the previous week. The previous week was concentrating on getting used to a little bit of light programming and seeing what we could do with some data files and things like that. This is still doing that sort of thing, but I'm trying to get you used to the notion of doing a particular task, and it's kind of projecty, okay? To that end, we're also doing stuff that I'm not really used to doing. So bear with me a little bit as I'm learning some of it as you're learning it. So for example, for today's assignment, I had originally intended to involve Excel and Sheets and maybe CSV files, but I backed off on that because of the fact that it just haven't quite figured out how to do the Sheets version of it, even though Sheets is usually easier to do things with. So for me. So I'm going to have you doing a project that's dealing with an Excel file, okay? And I'm going to show you an Excel file. It's a spreadsheet. If you've never dealt with an Excel file today, will be a little bit of a misery because you'll have all sorts of things to absorb all at once. But we're going to look at that real quick. And, okay. So this is, and I think it's just showing you one of the spreadsheets. If it's showing you two of the spreadsheets, bonus, I guess. But the spreadsheet in question should be titled example.xlsx, right? So when you look at a spreadsheet, it has several features to it that we should talk about. The first thing is that you have columns that are lettered, A, B, C, D, etc. If you've opened up a CSV file with Excel or with Sheets, then you've seen data organized in this way, but that instead of having letters for names had names for names, names of columns, all right? So then you have rows with numbers. And so in particular, if you talked about the data that is inside this cell here, you would say that it is in A1. Hopefully that is super simple and straightforward to follow. Down at the bottom of this, you'll see these little tabs that you can go to, and they are labeled sheet 1, sheet 2, sheet 3. So rather than thinking of those as tabs, think of those as different pieces of paper that are stacked up there, and they have names, sheet 1, sheet 2, and sheet 3. If you need to refer to a particular cell on a particular sheet, let me phrase that differently, a particular cell on a different sheet, but within the same workbook, then you would say sheet 1 exclamation point A1, or sheet 3 exclamation point D7. Okay, should be pretty straightforward. But if you're on the same sheet, you can just say D7 or A1 or whatever it happens to be. So that's the basics of spreadsheets that we're dealing with here. Excel is a Microsoft program. It is not free, but you, as a Guilford College student, can download it and install it on a machine if you need to deal with it. However, what we're going to be doing is taking advantage of the Excel API, and it will let you do things to spreadsheets without having Excel on your machine. And I tested this by going to the machine that I have at home. It's a desktop computer. It's a Windows machine. And somehow the Office 365 installation that I put on it several years ago has gotten uninstalled. Maybe my kids did it. I don't know. But in any case, I wrote the program that we're talking about today on a machine that did not have a working Excel installation and did it. So the thing is that Python's taking advantage of the API, which I know the I stands for interface, but I don't remember what the rest of it stands for. But lots of software has an API that you have the descriptions of how things work, and you can grab data and stuff in certain ways, but it's protected and you can't actually get in maybe and see how it's working. So anyway, though, so keep in mind, we're dealing with Excel. You don't have to have it installed on your machine, but if you do, you can open these files and look and see what's in them. Okay. A valid question at that point would be, well, why don't I just do this with Excel then? Totally makes sense to do, except the assignment for today is going to have you telling Python how to sort through several thousand entries. I think it's like 50,000 entries, and reduce them down to maybe a couple thousand entries. I don't remember the exact numbers on this, but you're going to deal with a very large amount of data and make it into a just large amount of data. Okay. So anyway, let me talk a little bit more about how to get going on this, and then we'll go from there. So I am going to share screen again, and this is a little difficult to figure what it is I'm going to share. I guess I'm going to share this one here. Okay, you may see a whole mess of stuff there, and I'm going to take and minimize a bunch of it. Actually, that I'm going to go ahead and close. Well, I assume you can see this here. This is the census population data that will be the actual assignment that you'll turn in will have to do with this. Okay. And notice down at the bottom, it says population by census tract. Okay. But I was going to close that, but then Zoom put something in my way. Oh, and then it moved. Okay. Yeah. All right. So, okay. First of all, here is the actual page that you'll be doing starting on the assignment from. There are these two files. Okay. And you will need to download them. If you've downloaded them already, we should wait, but I'm going to show you what to do with them when you download them. All right. Because what you are going to need to think about doing, here's Anaconda. Okay. What you're going to need to think about doing is making a folder. I'm on a Mac. If you got a Windows machine, there's very similar things going on. Make a folder. I called mine Excel assignment. You can call it whatever you want to. All right. And in that folder, you need to get the census population data and the example spreadsheet. Okay. You'll need to deal with both of those. So get them both into that folder, and the documents, the notebooks that you're going to create, you'll want to save them to that folder as well. Okay. Why do you need to do this? Because I don't want to try to explain the whole idea of relative paths and stuff like that. Okay. If you know how to do relative paths and understand what's going on with that, great. Go ahead and deal with things that way. Okay. You can make the adjustments that are needed. But this in particular is the reason why I can't quite follow how to do this with Colab. So you'll need to go ahead and do this with Anaconda unless you can figure out how to do it with Colab. Okay. I'll leave that to you. I would just do it with Anaconda if I were you. But notice that I have put in here census pop data example X and the example one, those are where those you have links to them, but you can also access them from another direction. And the end result you're going to have is the Excel handling. Okay, Excel handling IPy or Jupyter Notebook. Put your name in the name of the file. Okay, so mine would say Ben Marlin Excel handling. So I'm going to go ahead and do that, give you an example here. So Ben Marlin. Okay, so if your name is John Doe, you put John Doe Excel handling, right? I need you to do this because of the fact that I'm going to download a bunch of these things and take a look at them. And they're all going to land in the same folder. So I need you to help me out that way. Similarly here for census population data, which you'll make as you go along. Well, nope, that's not true. Okay. At the end of this, we are going to have another file that you will be uploading, and we'll say something about that as we go. All right. So you got that in mind. That stuff is going to be inside this Excel assignment folder. Wherever that is on your computer, you have to figure it out and know where your files are going to be. All right. Then I am going to come back here to my Chrome thing. I'm going to point out something here. So with regard to the assignment, we are working from a book that it's a series of books actually that I really like how they do things. They talk about how some Python things work, and they give you very concrete examples. But I give you a link here, and then there's also a PDF if you want to use a PDF instead of going to the site online. So it's called Automate the Boring Stuff with Python. If you scroll down here, you've got a table of contents that jumps you to things. We're going to be talking about working with Excel spreadsheets. If you want to learn things about working with Google spreadsheets, go ahead and go to that as well. But we're going to concentrate on that for now. All right. Read it. Read. So you will notice here that they do things like saying import open pixel. I guess that's how you pronounce it. Notice it has 3 greater than signs and a space at the beginning. When you copy and put this into your notebook, don't copy the greater than signs. If you can't avoid copying the greater than signs, like if you accidentally do that, you have to delete them and delete the space at the beginning of the line. Your Jupyter notebooks will not execute it if it's got a space at the beginning because it's stupid. But you have to figure that part out, but it will walk you through exactly what to do. Now, everything it's got has in mind the notion of putting this inside of a .py file, but leave it in a Jupyter notebook. You can take little pieces of it, and as long as you're not breaking across a loop or something, you can execute just one piece in a cell. So for instance, here, if you went ahead and copied this part here and jumped over to, don't do that. Sorry, it's covering up my tabs. And if you jumped over to something here, and I am going to insert one. Can I just drag that up here? Nope, I can't. Fine. But I would insert it in there. I would go to the beginning. I would delete. Okay. And I would have it doing stuff. Okay. But I don't actually need that because that's actually the first thing I've got typed here. Okay. So in any case, keep that in mind as you go along, that you're going to be able to just go ahead and copy a lot of, not all of, but a lot of the code, and it's just set up for you already. Okay. But read and understand what it is that you're doing there. I'm not going to read that whole thing to you because that would be kind of insulting to you. All right. But insofar as the notebook itself, notice I've got Jupyter Notebook running, and it shows you your folders here. And the folder I made was Excel assignment. And if I want to make a notebook, I tell it new, tell it Python 3, and it makes a new notebook. So you will have to do that because I'm not giving you the completed notebook, right? And of course, to change the name, you go up there, click on it, make the new name, you know, Ben Marlin or whatever you happen to be doing. Okay, so we will go look at that stuff here in a second, but I wanted to also point out that here with Automate the Boring Stuff, it's going to walk you through doing some stuff to the example Excel spreadsheet. Go ahead and walk through and do that stuff, all right? And we will come down here to the project. Where does it start? Sorry, this is, okay, project. So we're going to go to this project, which is about dealing with some population data. And I showed you the Excel spreadsheet that has that population data in it. Okay. So with this data, it has census tracts. So I don't know exactly what they are, but there are defined different areas of the country that are tracts. So they are certain areas. And the census takers are collecting data about how many people live in each of these tracts. Yeah, they're geographically laid out, and probably there's a way to look them up on Google Maps and such. But each tract will have a particular state it's in, particular county it's in. It doesn't have the city data, or doesn't have the city put in there. It would be nice if it did, but this is the population data from 2010. If y'all do some searching and find the same data from 2020, let me know, and then we could all use the same data, or we can all use the updated data. So you're going to be dealing with a spreadsheet that has that information on it, and it's on a, we either say a sheet or a ply. I think Apple stuff, they refer to plies instead of sheets. In any case, though, we're going to deal with that, and you'll notice that we have code already written for us that shows you how to get things read in, okay? And upon getting stuff read in, it's going to have you creating a new data structure. Let me zoom in on this to talk about it a little bit, all right? So this data structure is referred to as a dictionary. This was new to me, although I mentioned it to my 12-year-old daughter who is in a JavaScript class, and she knew what dictionaries were. So apparently this is just a piece of programming I've not run into. So the thing that you're going to populate with this code is a dictionary that will start out with a K, that's the abbreviation for Alaska, and then a colon, and then another curly bracket in here. And the first curly bracket in has Aleutians East, and then you'll have Aleutians West, and then you'll have Anchorage and Bethel and Bristol Bay. These are all counties in Alaska, okay? But underneath Aleutians East, see that colon means it's going to have something underneath it. It has this data here: population 3141 and number of tracts 1. Okay, So the code that you've got has taken the various tracts that are lying in it, and it will add up the populations and count the number of tracts. Follow through what they talk about in the book, and it does that step by step. Okay. But this will be something that you can ask the notebook to print out for you. And I believe I have actually asked it to do that for me. Okay. And you'll notice this is every county in the US and the population for every county in the US. That was not what was in the file. What was in the file was the population of every tract, and then they were organized by county. This takes and puts them together. Okay. So hopefully you can see that that could sometimes be a useful trick to be able to do, to accumulate things together like that. But what I'm going to want you to do from this that's not in there is to write another cell where you find out what's the population of your home county. So my home county, I grew up in Christian County, Missouri, and apparently in 2010, the population for it was 77,422. Okay, so I want you to go ahead and get that. So what you'll need to do is to, yeah, you can see what it should do here. My home county pop equals county data, square brackets, state, square brackets, county, and square brackets pop. So you'll get the population for your home county. Now, there will be a lot of y'all for whom your home county where you grew up is, right here in Guilford County. So in order to be a little bit more interesting, go to Wikipedia and find out where somebody famous grew up. Dolly Parton, for example, famously grew up in West Virginia. Let me see if I can open this up. Wikipedia, Dolly Parton. I just name her because she came up in the news today that she's a philanthropist and has done a lot of cool things. So she was born in Pittman Center, Tennessee. So I can go there and find out where Pittman Center is. And Pittman Center in Sevier. I'm not sure if this is Sevier or Sevier, but Sevier. So I can go back to my cell handling here, and I can say West Virginia, Sevier, enter, boom. Oh, it gives me an error because I have not executed everything here. So sorry, folks, but I'm not going to bother with it. I'm just going to say that I want y'all to do that and get yours to work. I had not executed some of the other notebook cells. So I'm viewing this on a machine, which was not where I wrote it at. So sorry. But then I want you to figure out something here. Notice here that I figured out that if I told it to print the information that's its sheet, well, I had sheet defined first of all, which is part of the code that you got. And I tell it to tell me what's in sheet A2 and sheet B2, sheet C2, sheet D2, and that dot value on the end will read out the value of it. There are some other things that you can read out, like the index and the row and column and stuff. But usually what you're wanting to do is to get the value out. So when I did that, it went ahead and executed and told me that I think that's Alabama and Autauga County, that the population is 1,912. Okay, so yeah. The reason that you want to do that is that you want to figure out kind of how some of this is organized. And so the next bit I did was to come along here and tell this to print using a for statement. So I said, remember that was county data, right? For state in county data. The first level of county data was the states. So for state in county data. First one it'll encounter is Alaska. Although, why is it encountering Alaska? Weird. It encountered Alaska. It encountered Alabama before Alaska. Don't know. It doesn't seem like that would make sense. But anyway, so then for county, in county data of state, square brackets of state, okay? So that means it's going to go through each state, and then in each state, we're going to read out county data of state. And then the for will go to each county. So the first one apparently is Autauga County in Alabama. And then we're going to say X equals county data of state of county of pop. Okay, that will read out the population. And then I told it to just print state, county, and the population number. Boom, boom, boom. So we got it printed out like that. Make sense? Hopefully. Then, once you've figured out how the for loop works, make sure you get that to execute and print. It shouldn't be hard. I want you to do something new, and I don't remember for sure, but I don't think it really explains how to do this in there. So this is new. Take some notes here. We have a function for a workbook called create sheet. If you've got your workbook defined, you make a new cell, you type WB dot and hit the tab key. It will list all these possibilities for you. If you instead start to type create and hit tab, then it'll show you just the ones that match with what you typed already. Okay, but create sheet, I called mine county populations. You could call it something else, but it would be kind of goofy to call it something else. I don't know. Go ahead and call it something else. Yeah. But I told it to create a sheet. And so what that's done is it has not affected the file we have, but the virtual copy of the file. We read in a file that had these sheets, and this in the virtual copy makes a new sheet. It's not been saved yet. That's what we'll do at the end. But we will say our sheet here is going to be the workbook's county populations that I just made. And then I went ahead and wrote the titles across the top. So sheet A1, set the value to be the word state. Sheet B1, set the value to be county. Sheet C1, set the value to be population. Maybe you just want to put pop 2020. That would be good. Why don't you all put pop 2020 or 2010, whichever that you have data for, okay? Then I started out here with saying I want row to be equal to 1. You could start with your row to be equal to 2 if you wanted to, but you'll see why I'm doing this of row equals 1. So then I went ahead and said for state in county data, for county in county data. Those were those things that you did in the print statement. I'm going to tell it to take the row and add 1 to it. Since I started with 1, it will add to it and become 2. Next go round, row 3, row 4, etc. You get the idea. And then I said, hey, let's take the variable x and let's go ahead and read out the population data from this county data dictionary. And then in the sheet, which we just defined, in A plus string of row, okay? So you have to put the string there because it doesn't always know what to do when you tell it to add a string and a number. It should default to making the number into a string, but sometimes programs don't work the way I think they do. So string of row, because this is similar to something that was done in the book there. Take the value, set it equal to state. So as you go through this, what it's doing is you've created a new sheet, and it went and put the titles up at the top, and then it just goes through and populates each row with the populations of the counties. If you'd like to also add a D column and put the number of tracts in there, you can do that, okay? But remember that the original data had each individual tract and its population, and this has aggregated the ones that are in each county, okay? Then at the end, I want you to take the workbook, and it has a function called save, and tell it to save to, I have here updated pop. That's not what you need to save it to. You need to save it to Ben Marlin pop. No, you need to save it to John Doe pop, or Fred Johnson pop, or whatever your name is, okay? So tell it to save that. You're executing each one of these things as you go along. When you execute that, it will save this workbook that you've done stuff with. Boom, you're done. Okay. Then again, oh, I need to point this out to you again. Again, if we go back to, no, don't create. Hate this. There's no way around this. Okay. If you go back to the assignment, what you need to upload is the notebook where you did the project. I don't care about the notebook where you did the practice stuff, okay? Maybe I'll subtract 1,000,000 points from your score if you, or something, I don't know. You know, don't turn in the practice stuff. Turn in the stuff about the project, okay? The project. And here I said something about updated pop.xlsx. I will edit that so that it says your name, pop.xlsx. So the Excel spreadsheet that you should be turning in to me should have 2 sheets in it, as opposed to having 1 sheet in it. And what I'm going to grade first off is I'm going to look and see, did your Excel spreadsheet, did it have the right stuff on it? That's going to be most of the grade, okay? If it doesn't have the right stuff in it, I'm going to go read your code, okay? I will scan through your code anyway, so don't just turn in weird, wild stuff, you know. But I'm going to look through your code a little bit to see what you've got going on. For the most part, this has walked you through it. Why are we doing this? Well, Excel spreadsheets, comma separated values, and sheets spreadsheets. Data, huge amounts of data come in those. And one of the big things that we end up doing is aggregating data. One way to do that is with things like dictionaries. It's not the only way to do it, but it's one way to do it. So I thought this would be a good assignment to just get you used to some file handling and to see how we do things with reading in and putting back into a file and stuff. So anyway, my plan is that this should be relatively quick and easy for you to do. All right. Remember, you're turning in 2 files. One is the Jupyter Notebook, and the second one is the Excel spreadsheet. The Excel spreadsheet you turn in needs to have 2 plies in it, 2 sheets, one with the initial data that came with it, or that came in the other file, and the other one with the updated data that you will be writing code to do. All right. I've not given you any code that's pre-written. You have to make your own notebook, and it should be named whatever your name is, Excel something dot IPYNB. All right. Good to go? Hopefully. All right. I will see you in class Monday.